Okay, we are in chapter 7, which is, what is this called? Alternating series and other tests. Day number 1 on the integral test. Okay, so I want to start with this thing. If I took the sum of this as n went from 1 to infinity, what would my first term be? 1 over 1, right? Come on now, show up. There you go. 1 over 1 plus 1 over 2 plus 1 over 3 on to infinity. Okay, so my first level, I'm going to test for convergence of this because it looks like it might be a candidate. So the first level would be to test the limit as n goes to infinity of a sub n, which is 1 over n. And what would that go to as n goes to infinity? 0. So hey, it's a candidate. Great. I have to do more work. Right? So now I go to the ratio test. Okay, so ratio test. So I'm going to take the limit as n goes to infinity of a sub n plus 1. So this would be a sub n plus 1 over a sub n. Okay, I'm going to take the limit of that. Well, if I were to actually reduce that, limit as n goes to infinity, instead of dividing by 1 over n, I could multiply by n over 1. So you'd see that I'd get the limit as n goes to infinity of n over n plus 1. Aw, what's that limit? 1. Great. So the ratio test, if I get a limit of 1, it means inconclusive. Oh, thanks. Great. So now what do we do after that? Now we do the integral test. Inconclusive. Yes, correct. Now, one thing, if you get an inconclusive result for the ratio test, the integral test should be the thing that you go to next. However, sometimes functions are not integratable. With me? So if they're not fun, then you're going to have a different test, which we'll talk about later. But I can integrate this. I can integrate this relatively easily. So I'm going to take, and in step 3, I'm going to do the integral test. So here's where the integral test comes along. Now I'm going to teach you a little bit about the integral test as I do this. 3 things have to be true about the function. The function I'm going to call at this point f of n equals 1 over n. 3 things have to be true. It has to be positive for all terms. Is it positive for all terms? Yeah, it's 1, it's 1/2, it's 1/3, it's 1/4, so we can say check. Is it continuous on the interval? Meaning, are there any vertical asymptotes potentially, or holes? No holes, no vertical asymptotes. It's continuous. And the third thing is, it must be decreasing. Is it decreasing? Yes. Now, in some cases, it's not easy to tell. So you might have to take the derivative of the function and show that the derivative would always be negative or less than 0. Calculus. So now that we know that the function 1 over n is positive, continuous on what interval, by the way? From 1 to infinity. Now we're taking it from disjoint values of just the sequence 1, 1/2, 1/3, and we're taking all values in between 1 and 2, 2 and 3, etc. We're turning this explicitly disjoint sequence and turning it into a continuous function, right? So now we take the integral. Move that out of the way. From 1 to infinity, oh, improper integrals, you're not going away. Thank you. Of 1 over n dn. And we're going to show one of 2 things. All right? If this sequence converges, or excuse me, if this function, after I integrate it, converges, right, then we know that the series converges. If it diverges, then series diverges. Okay? So let's integrate. What is the integral of 1 over n? Yeah, ln of n. Ln of n from 1 to infinity. Oh boy, when I drag this, everything's going to disappear. You ready? Actually, it's going to move with it. Oh, what just happened? Uh-oh, problem. Okay, let's move this. It's going to try, oh, hello. Oh, it worked for me. Thank you. Okay, cool. All right, so what do I do next in an improper integral? One to what? What do I label infinity as? B or A or any variable that I want. So I'm going to take the limit as b goes to infinity of the natural log of n from 1 to b. All right, so I plug in. I take the limit as b goes to infinity of the natural log of b minus the natural log of 1. So what will happen to the natural log of b as b goes to infinity? It'll go to infinity. And of course, the natural log of 1 is 0. So infinity minus 0 is infinity. What does this tell us about the series? It diverges. Okay, it diverges. Because the integral diverges, because the integral from 1 to infinity of 1 over n dn diverges, then the series from n equals 1 to infinity of 1 over n will also diverge. Of course, those first three criteria, positive, continuous, decreasing, have to be true as well. Check this one out. Do laws of notation allow me to do this? Is this legal? Is that legal? Yes or no? Yes, okay. The first one is red alert, right? P series tells me what's going to happen to that series. Diverge, okay? So I know that it'll be some kind of infinite number. P series tells me this will converge. This will converge. So infinity minus some finite number is still going to be infinity. What would be true about that original sum then? It will diverge, right? I could do the integral and show that I'm like good at integrals. I'm so good at this, right? But I don't really need to. All I needed to use was P series. That's why it's your friend. 1 over n is going to diverge. 1 over n squared will converge. A divergent value minus a convergent value will still be divergent. Pretty good. Pretty good. Let's go. Let's keep going. Okay, gross. How about this one? I can't use P series. I can't use P series, right? Because it's not, I don't have, something isolated in the denominator. Could I use comparison test? Probably. Probably, but I'm not gonna. So I'm gonna use the integral test because that's what we're practicing, right? I'm gonna take the integral from 1 to infinity of n over n squared plus 1 dn. Who sees it right now? What would you do to integrate this? U sub, good. What would U equal? Yeah, I would set U equal to n squared plus 1. So du would be 2n dn, which would mean 1/2 du equals n dn. Oh, yeah, this is good. So this would be the integral from 1 to infinity of, how would I write that? 1/2 I'm going to replace this. I'm going to replace this with what? 1/2 du, right? I'm going to replace this with what? 1 over u. Oh, natural log. Hello, my friend. Natural log, as it goes to infinity, what happens to it? It goes to infinity. This will probably be divergent, I would assume. Okay. Does that make sense? Okay, so this series right here, if what we've got here is correct and our work is correct, if we get an infinite value for our improper integral, this will diverge. Of course, there are the three properties that I have to confirm at first. Is this continuous? It's probably not in the same order I wrote it before. Is it positive? And is it decreasing? Okay, I think that's good for right now.